All right, so I totally blanked on the fact that midterm reports were due yesterday for y'all, so you wouldn't have gotten a satisfactory or you wouldn't have gotten an unsatisfactory remark from me because I completely forgot to do them. It's been busy at home, so sorry about that. But suffice to say, if you have if you've got like I said, a 65 below in the first exam, definitely be concerned about that. Definitely want to talk to me about resources, about ways I can help you. Similarly, if you've got homework that you haven't turned in yet, you want to definitely try your best to catch up on those. And again, meet with me and I can help with you. I'm definitely available over Zoom to do those things, although it's becoming, on Wednesday evenings I'm still going to hold those office hours. It's just Wednesdays in general I've turned out to be a lot busier. I'm not going to go into my personal life, but turns out that parenting is a lot of work sometimes. So Wednesdays have just become that busy day. So, but other times I am totally available. So, just feel free to reach out, and I'll try my best to get back to you at a reasonable time. And if I've not get back to you, don't feel bad about poking me with another email. Some professors, that will really annoy them if you send another email because they didn't respond. That's going to really tick them off. No, I'm just going to go, oh, crud, I missed that. But I went through I was going through Runestone this morning and just had a 5-minute timer on my phone. I figured out a system finally where I put a 5-minute timer on my phone and hit the run button and then swap back to the tab every time it goes off. So anyway, I've been updating those, and I'll be doing an import. And honestly, it's not a bad time about this because it's time to show you my script. And there's parts of this that you won't understand yet, and that's perfectly fine. But we will be able to read through it and understand certain parts of it. Parts of it we are actually going to be learning today, okay? Long story short, how does my importing your grades from Runestone into Canvas work? I'll do it a few times this semester. Once I do it basically this week. The way it works is that I've got 2 grade books essentially, with 2 systems that I don't have talking to each other. I could ostensibly get them talking to each other, but I like to keep things independent in case the bug on one goes completely haywire on the other. And honestly, this system works for me. It ain't broke, don't fix it. So what we've got here is I basically get 2 CSV files and I need to create a third one. Okay. Part of that and I'll get into that create a third one in a bit. So first thing we do is I've got your canvas.csv, which we'll see over here, and I'll explain the with opens in a second. Just know that we have a canvas.csv file, okay? Canvas.csv is basically your Canvas grade book. It is basically first name, last name, student, TUID, TUXXXX number, right? And then basically each row, and then each column is like a different grade for you. Like assignment 1 is its own column, lab 2 is its own column, exam 1 is its own column, and it just simply has those totaled. And Runestone does the exact same thing except for the Runestone account information and your grades in Runestone. And so what I need to do, so if I was doing it by hand, what I would need to do is for every name in Canvas, find your name in the Runestone thing, and basically copy the appropriate row in Runestone to follow the appropriate row in Canvas. Now, why can't I just simply grab an entire square and just move all of one to another? And the answer is because some of y'all are terrible, but not any of the ones here sitting here in class because you're actually showing up. No, some of y'all are the ones who will not be seeing this video, just never show up to class and never try, but they register, but they're sitting in my Canvas workbook, even though it's just like 1 or 2 students who just don't turn in everything. This happens every semester, by the way, where there's just 1 or 2 students who they sign up for classes and never show up, and they just populate the book. So I can't just copy everything over because they never signed up for Runestone. So that would create gaps. So that's one reason. And the second reason is that people sometimes are actually good students, or sorry, I should say they're responsible and realize, oh, I'm going to just search for 18 hours. That's a bit much. Well, you know what? I'm a physics major. I'm going to focus on my physics core, and I'll leave the programming for another time. And they drop this class, and that removes them from the roster. Perfectly reasonable to drop this class, by the way, or any class, you know? It happens. I've been told by other advisors to not say this because they consider it bad advice, even though it worked for me. I totally would register for 15, 16 hours every semester with the full intention of dropping one, and I did about half the time. Now, the reason being is that knowing I could drop a class made things a lot less stressful for me. Just knowing I could, knowing that I wasn't doomed. If I fell too far behind, I could say nope to that class, and yes, it would show up as a W. But in the S, they would say that doesn't look good on your resume or whatnot. But honestly, what do they look for first on the resume / your transcript? The GPA number. And let me tell you, when it doesn't get factored into your GPA, it helps a whole lot. So yeah, my transcript, which if you're interested, just DM me and I'll be happy to post it on Discord. Actually, I can go ahead and see if it is still on Discord. I'll be happy to show my transcript off. Because it is not actually showing it off. This is the opposite of a humble brag. This is just humble. I was actually very good at graduate school, but it took me like forever and a half to be good at undergrad. The standards are different. Anyway, again, I didn't want to necessarily post my private information. You can look it up in the Discord. Just search for my transcript if you're interested to find those stuff. I'm happy to share it again if you need a bit of a confidence booster there, because again, I was not a good student. A lot of time playing MMORPGs when I could have been better allocating my time. All right. So let's go into how this works now. So first off, first line, import CSV. That just simply does a bit of automatic magic that I don't even remember how to do anymore for writing a file. That's all. Rune hash, rune emails. These are dictionaries, these curly braces. Where in the world are those on the keyboard? Those are right above your enter key and your apostrophe key on a standard US keyboard. They're the shift version of the brackets. You're pretty much if you're in programming, you're pretty much one of the few human beings who will ever actually use these. But for right now, know that these do dictionaries and think of them as special lists, except anything can be an index. And that's what we're going to learn later today. With open runestone.csv as runestone. So effectively, you can think of this as me doing this, which is saying, hey, runestone. This is just like a bit of a more safer and preferred way of opening a file like this. Runestone is equal to open runestone.csv, but I didn't want to have, but I like to keep things as simple as possible, which is why I prefer to do this in class, because it was less syntax to have to learn, less having to learn about indenting, right? Just know that basically this is a bit of a safer way to do that, in the sense that, like, we're messing with files, sometimes you can read and write stuff, and so if you're doing a lot of read and writes at once, this can be a bit of a safer way to play with files. Not something you ever have to worry about in this class. Okay, so what I do is that I open up the Runestone file, and then and basically this is just reading it as a CSV file. It's just basically, doing the whole break. This basically does the whole, I'm going to read the file and break it up in kind of one line for me. Okay? And then I turn it into a list rather than just one thing. I turn it into a list. That's what this line 8 does. It says I'm going to make it a list so I can go line by line in my CSV file. I get rid of the first two lines because line 1 is the legend, and index 0 is the legend. Index 1 is the amount of points that is worth. That is basically the only manual part of this I ever do, which is, and I could probably automate that, but honestly, it's a pain. So, but they're not your names. Now, what I do is I figure out what in the world your name is. That's what this next part is. Line 10, name equals, and then I'd say, hey, your name is, now Runestone likes to put it first name, last name, and Canvas likes it last name, comma, first name, so I go ahead and switch it over to the way Canvas does it, which is I take your last name, row 1, dot capitalize, which takes, it's a very nice function, capitalize. Capitalize is, here, give me 1 second, just pulling up idle for a second. Idle is kind of useful for just showing off, hey, if I do s is equal to hello, or actually, let's go with my name is Andrew, okay? S dot upper would basically turn it all into shouty case, sorry, uppercase. My name is Andrew. So, S dot lower would put it into all lowercase, and S dot capitalize does my name is Andrew. It capitalizes the first letter, essentially. So it follows capitalization rules. So it takes that, it makes sure the first line is capitalized, and then it strips out any preceding or trailing white spaces you might have, any space you may have accidentally put in. Then I add in a comma and a space to separate your first name and last name. And then I put in and then I do the same thing for your first name. Now, Rune emails says row 3. So the fourth row, in other words, row at index 3, the fourth row, is your email address in the CSV file. Now, the reason I'm not showing this file let me make sure I've resumed recording, by the way. I believe I did. Yes, I did. The reason I'm not showing you the actual file is because that would be a FERPA violation. I can't actually share, because I'd be sharing everybody's grades with the entire class, and I'm not supposed to do that. That's private information. It's part of the reason why if your parents email me, I can't, but my canned response is, I'm sorry, I can neither confirm or deny that this student exists. You know, there's specific kind of paperwork that has to be involved because it's private information for adults. So, anyway. So you just have to take my word for it that basically that this row has your email. And what I do is that, as we'll see, what hash maps or dictionaries or associative arrays, as they're called in all different languages, what they do is they can create bindings between key value pairs. Basically, I'm creating a special list that says, rather than given this index, give me this data, I'm saying, given this email address, give me this name. If I give you the email, give me this name back. That way I can look up who you are based off what email you put in. And then I do something even a bit more powerful where basically I say, hey, the rest of everything from row index 4 on are your grades. They're just your numerical grades for Runestone. And I say, create a binding between your name and your entire list of grades. Just simply all those rows. If you didn't have one, it's a 0 or a blank, it doesn't matter. It's a CSV file. So I'm gonna be able to use that so I can copy that in. All right, so now file writing with open CSV W and new line is equal to this. This basically says, hey, don't put in when you put in a new line, don't put in a new line /n. Just let me do that. I'm going to handle all the new line stuff manually. And then as output, right? So I'm creating a new file here called output.csv, and that's what I upload to Canvas when I'm done with this. And I say, here, I'm going to use a CSV writer so I can just write this easily all at once. Okay? And now with open Canvas as the Canvas file, so open up your Canvas grades, and then I basically say for every row in the Canvas grade, I'm going to try to find you. So I get your name, which is So here I get your name, I strip any beginning or trailing white space, and I get your email address. Canvas will have your TU something, 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 and so I can get your email address by using your TU, your TU number +@ temple.edu to get your email address. That's why I told you, hey, make sure you sign up with your name or your email address when you're signing up to Runestone, because my script will then be able to find you. So I basically say, hey, if your name is in here, if it's one I found, awesome, I found you. Just take all the data you currently have and add the stuff from Runestone onto it. That's concatenation. That's all I do. If I can't find your name, well, maybe you did your email address like I asked, and then it will catch that. It will figure out your name from your email address, and then it will do that. Otherwise, I do some hackery here, which actually sometimes works with removing the middle initial, because your middle initial might be on Canvas, but it might not be on Runestone. So I do some hackery there. And if I find you, awesome. Otherwise, I just don't find you, and then you're like one of the 3 people I'll have to put in manually later. And that's fine. And that's it. And what it does is then I just upload this, and it just replaces all of your grades with all those empty grades with your current grades. So you'll get a whole lot of notifications all at once. So the reason I'm showing you this is that this would normally be like a 2-hour job of just simply taking things and manually putting them in and looking and trying to compare name by name and finding out where, oh, wow, okay, the Americanization or Anglicization of your name, which you prefer, got really weird, and so you're an edge case, and that's tough. This automates my job. And if you're not a computer scientist or in computer programming, that's a lot of what I want you to get out of this class, which is I want you to be able to take things from this class and automate a lot of stuff that would be extremely time-consuming for you to do. There's tons of libraries in Python for automating stuff. You can literally write a script to control your mouse and keyboard so that it will click the appropriate parts on a web page, so it can automate your key presses and entering stuff. And basically you can spend, yes, you might have a job that takes you an hour, but you could spend 2 or 3 hours of learning and writing, and now that job turns into a 2-minute job every time you need to do it from now on. It pays itself back really quickly. Automating. Remember, computer science, what we're asking in computer science is the study of algorithms. We ask what, when we get right down to it, can be automated, and the answer is, honestly, a lot. A lot can be automated. Okay? I've created scripts that help me figure out what the half-life of medication is, so I could figure out, okay, this is when I should take my next dose optimally, based off of these assumptions. Okay? I've done things in my life with computing which helps. I've done things that automated sending out, randomly generated passwords to all the users in the class for something that, rather than sending an email to everybody, one at a time. This because I can't just send an announcement out because I have to send a different password to every student. So I've automated that rather than spending that time. And so it's one of those things that I say you got to be aggressively lazy, essentially. It's a special kind of lazy that computer science allows you to be. It's the kind of lazy where you say, I'm going to put in the hard work of maybe spending a bit of extra time now on this task so that next time I can just slack off. That's a lot of what I do. I like being able to do that. It feels really good that when I go to do something again, it doesn't take that much effort. Okay? It's a very good feeling. Okay? Now, so anyway, that is kind of what we can do here. So I'm going to go talk about, in more detail about these associative arrays now, which is essentially the last, I guess, thing built into Python we're going to learn. After that, we're just going to learn topics, essentially. So the way the rest of the semester goes is we learn dictionaries, because they're extremely powerful for learning how to solve problems. You won't encounter them formally again until the third computer science class, where they're taught as hash maps, but they're extremely powerful, and you'd be bereft of knowledge if you didn't know about them. Similarly, then I get to talk about, I'll talk about topics that are near and dear to my heart. One will be mandatory for you to learn because I like it that much, and the other, well, I like it that much, I can't justify doing it, and it'll be more of an extra credit thing, which is regular expressions. Although it is on the third exam, so I guess technically it's no longer optional. I mean, technically the third exam is optional if you've done well on the other. You get what I'm saying. The point being, though, is that I'm trying to teach things that are going to be very useful to you no matter what you're going to end up doing, right? Okay, so, and dictionaries are extremely powerful at being able to basically store data and create binding between data. Monte Carlo, which is the next topic, is extremely powerful at being able to do math when you don't actually know how to necessarily do the hard statistical math. Why? And it gets into this whole technique that I love, which is, why do hard math when the computer can give you an estimation that's just about as close? And then finally, we'll learn regular expressions, which is the extremely powerful version, souped up, turbocharged version of find replace that's built into in most applications. In fact, most applications do support regular expressions simply because they are that powerful and programmers just love them. It's one of those things where if you spend 2 hours learning it, it will pay dividends back in any kind of computer-related task. Okay. Dictionaries are near and dear to my heart because I did my research dissertation on something called distributed hash tables. Hash tables are kind of the backbone of these dictionaries, and we're not going to get into them. I do in 2168. I go over how to build them from scratch, and if you're interested, there's an entire playlist on the YouTube channel for 2168 that you can watch, where I go, here's how you use these in Java, and here's how we build them from scratch in Java. Very useful stuff. Very powerful things. In fact, it became a bit of a meme in the interviewing community that we have to find better questions that can't just be trivially answered by using a dictionary or a hash table. So they've got benefits here because they are extremely quick, extremely efficient, and extremely powerful. So we've learned about lists, right? I've got this list L, and I'm going to create a list, where I'm like, let's see. So L's our list, and it's, you know what? I'm just going to create a list of numbers really quickly. Range. Let's go with 97 to 97 plus 20, and we'll turn that into a list. And that turns into a list of numbers. And there's all sorts of fun things you can do in Python that I want to just brag about because it's just so fun to be able to do something like this. Wild stuff like map. And this is stuff that you may not even have thought of being able to do. Ord L. So this is a function that took a function as an argument. So let's do that again. And this is not something you're ever going to be tested on. And I'm just going to turn that into a list. Ord is, ord. Oh, right. I have to map ord, string of length 1, but int found. Oh, darn it. Okay, fine. Lambda. I have to spell lambda correctly. Lambda x is equal to str x ord that. Will you be happy now? Yes, you're happy now. Okay, great. Yes, I'm doing magic. Hold on. No? What do you mean string of length 2 found? Word expected a character, but string of length 2. I was just trying to, what I was trying to do was just simply turn everything into a string, everything into a, wait, why didn't ord work? Ord should have worked there. Map ord out. Why didn't it work there? Have I forgotten how this works? Possibly. Ord, what that does, remember, is that it turns anything into a, it turns, oh, because I'm using the wrong method. Ord, silly me. Okay, ignore that whole lambda nonsense because I was just being silly. I was doing the inverse operation. CHR. There we go. So what this did is said, hey, for every number in the list, apply CHR to that, and then turn that back into a list. And that gave me basically the letters. Great. That was certainly not quicker than typing it out, but hey. So here's our list of letters, right? And what a list is that we've got this ordered things of letters. At index 0, we say, hey, that's A. At index 7, that's going to give me H, right? We've learned how list works. We also learned that we can add to the end of a list by using append or by using concatenation, right? So we've learned and we've learned how to iterate over lists. Fortunately, there are a lot of similarities between lists and dictionaries. The syntax is very similar, but the main thing is that lists concern themselves with order. You may disregard that order, you may not care about the order for some things, but there is an order that things have in a list. Dictionaries don't really have an order, they just have pairings. Okay, a dictionary, and I'll start a new window for this. Okay, idle. A dictionary, we'll use dictionary D. Uses the curly brace. So this creates an empty dictionary. To add something to a dictionary, we can just simply say, use an equal statement rather than doing append or anything. So I can say D1, or actually I'll do D5, is equal to apple. Whoops, D. And what this does now is that this goes from being an empty dictionary to printing out, hey, we've got a binding here between 5 and apple. What does that mean? Well, it means that if I ask the dictionary to give me 5, so I said, hey, take apple and store it in D5. Dictionaries with the key 5. That's what this thing is called. Rather than index, it's called a key. So given the key 5, I'm going to get apple back. If I give it anything else right now, like 1, it's going to say, hey, there's no key. It's going to give me key error. That means there was no key, right? Similarly, if I go D-7, key error, right? There's no 7. If I say D4, no, the only valid key is what I've put in, 5. And it is key value. It's like those functions, those abstract functions, those mappings that the professors make you do in algebra, right? The one-to-one or one-to-many, right? Or many-to-ones. Here we've got a many-to-one, which is saying that every key is going to be unique. And it goes from the keys to the values. It does not go the other way around. So if I say, hey, D apple, and yes, you can do that, we get apple. Key error, apple. So I could do D, and the keys don't need to be consecutive, right? D17, I'm going to say that's equal to banana. Okay? And so now we've got D apple, 5 is apple, 17 is banana. But the main thing about that, the main advantage of dictionaries is that pretty much anything can be a key, and pretty much anything can be a value. Sorry, yeah, pretty much anything can be a key, and anything can be a value. So, for instance, I could say fave, and I'll go with peach today. So 5, 17, banana, fave, peach. So if I say, hey, D of, what's associated with the key 17, it will tell me banana. If I say, what's associated with peach, sorry, it won't tell me anything because that's a value. If I say D, what's associated with fave? Sorry, I hit enter rather than quotation mark. If I say, hey, what's favorite? What's my favorite thing? And say peach. So with lists, everything was basically a consecutive index, right? 0 to the end of the list, right? And that index is always a number because we're like looking at different slots. Here, this is a bit more abstract. We're saying there's key value pairings. Okay, now why is this useful? Because it's very efficient. Because you can basically say, hey, what is this thing? Or what is the stuff associated with the thing? Given the student's name, give me a list containing all their grades. Given this person logging into the website, given their account name, give me what's in their shopping cart. Right? It gives me, so this is a very powerful association, just being able to directly look something up. It's also, again, I should mention, very operationally efficient. It works off of a technique called hashing, which allows it to look up this information incredibly quickly. If you've taken any more advanced computer science, you can assume that dictionaries operate in constant time, O of 1, with a honking big asterisk there that sometimes it takes O of n. But that's only if you've taken like some upper level computer science stuff by accident, right? Or mid-level computer science stuff by accident. But for the rest of you, you can completely ignore that. So dictionaries are super efficient. But they enable you to solve problems that we would normally have trouble solving. Okay? Let's go ahead and take a look at just kind of I'm going to go ahead and I'm going to go ahead and use an example right now. Okay? First, I'm going to go to a website to download a text file to work off of. And because it is October, I'm going to go to Project Gutenberg. Now, Project Gutenberg is named after the Gutenberg Bible. It's a very important project, which is that anything that's public domain in the U.S., any literature that's public domain in the U.S. can be found here. So this is old classic books, anything that's basically more than 100 years old. There's a certain range of copyright. It's been around for a while. It's in a ton of formats. So let's go ahead and look up Mary Shelley's Frankenstein. It's Frankenstein. So there we go. Project Gutenberg, only 700 downloads, really? Oh, there we go. Or the Modern Prometheus. So there we go. This was the 84th upload to this website. And there's other things over here where we can see, like, hey, read now. You could just read it online. And you can read the entire text for free. Like, so if you're assigned an old document, an old book in your English class, you can come here and get it. Easy. All the works of Shakespeare and all that stuff. Although really you shouldn't be reading Shakespeare, right? If you take, I always recommend students take Shakespeare as a literature option if possible, because then it becomes mandatory movie watching like once a week, as opposed to reading it, because it's a play. You are meant to watch the play, not read it. Okay? Anyway, but the file I'm interested in over here is this plain text UTF-8, our .txt file. I'm just going to go ahead and save it to my desktop. Or, I guess, Documents CS1, which is where I'm saving it. And it's named pg84.txt, Project Gutenberg 84, and I'm just going to call it Frankenstein instead. Frankenstein.txt. Now, I need this file because I need a, as we say, a corpus, a large batch of text to read, okay, for my example. So I'm going to create my, I'm going to go ahead and back to Documents. I'm going to go to the folder that I created over here, and I'm going to call this one file. I'm going to call this file counting because we're going to do a lot of counting in this today. So this is going to be going over, so this is basically a nice transition between file reading and what we're going to be doing because we're going to be reading file again. File counting. Okay. So let's first make sure we can open this file. Open Frankenstein, right? It's a quotation, so Frankenstein .txt. Make sure I can open it. Run. Yeah, it can open. Great. I'm going to make sure I can read it. Give me a second. That's actually important with files from Project Gutenberg on Windows. Right, okay. So with files on Project Gutenberg, I occasionally have to do this, where it says, hey, I don't understand some of the letters that you downloaded. They're not Windows friendly, and I'm like, you kidding me, Python? So this line, this is why I do the Pokemon instead as my example now. This line is important right over here, but only for Project Gutenberg stuff. So encoding equals, and some of this, and I've had to show this to some of the students who were using not English as their primary operating system's language, or as their operating system primary language. So let's go ahead and do that. Frankenstein.read. And now it reads just fine. Basically saying, hey, this is a UTF-8 file, not whatever you thought it was. Because text encoding actually was a pain in the butt back in the day, and this is an old website, so it uses some older formats. So, so just simply understand this is just a magic word I use with only with stuff that I use with Project Gutenberg. Okay. So I'm going to call this I'm going to say, hey, this is the file is equal to open Frankenstein.txt. And I'm going to say text is equal to file.read. I'm just going to read the entire file as one thing, right? Print text dot, not that, print out the first 10,000 characters of that text file, okay? And we can see I'm successfully reading this text file just fine, right? It's got a bit of a preamble up here. I'm going to just ignore the fact that it's got this preamble saying I got it from Project Gutenberg, it's copyright free and all that stuff. I'm just going to ignore that for my data considerations. If I really cared, I could just simply go through and cut that out, but I don't need to for this. So now I've got this. Let's talk about the kind of questions that are a bit challenging with what you know. Okay? Given this file, this book, what is the most common letter in the file? Now, you might be saying, of course, given a file of appropriate size, it's going to be E because it's written in English. And most of the time you would be right? Because E is the most common letter in the English alphabet. Except, of course, when authors are complete jerks who didn't have enough time because they didn't have cat memes or any social media. And so they do things like write the book Gadsby. Okay, Gadsby, which is a 1939 novel, written without words that contain the letter E. Because, again, I guess people had too much time on their hands in the year 1939. Not like there wasn't anything else important going on. All right, so anyway, so yes, it was a very difficult, so 50,000 words without the letter E, and he said it was it is, his primary difficulty was avoiding the ed suffix for past tense verbs. So a lot of constructions with did walk instead of walked. He could not write about any number between 6 and 30, pronouns, and many common words. So very constrained challenge for writing there. So let's actually say, given a file, I want to count, I want to know what is the most common letter in that file. So how would I figure that out? Now, the answer is that with the current way we know things, okay, with what we currently know, without using dictionaries at all, because again, if I'm talking, this is like the dictionary lecture, so the answer is obviously use a dictionary even though you don't know how to use it yet, right? Can kind of figure that out. Just, we call that metagaming. So, but knowing what we've learned already, right, we've got a couple of options, okay? Option number one, okay? Option number one is the most naive option, but boy, does it, but sometimes, my friend had a saying, which was brute force always works. And so brute force always works. A is equal to 0. B is equal to 0. C is equal to 0. D is equal to 0. Create one variable for every letter. I'm going to go ahead and stop there. And I'm just going to say, hey, just pretend I do that for all the letters from A to Z, right? Make sense to everybody? And then I've got this text. It's all the letters in the file. And I'm just going to simply say, for letter in text. Right? For letter in text, what am I going to do? I'm going to say, if letter equal A plus equals 1, the number of times. And so A is going to capture the number of times I've seen an A. And B will capture the number of times I've seen a B. And C will capture the number of times I've seen a C. And so on and so forth. And we'll do 26 if statements. Because why not, right? We'll do 26 if statements. And then we'll figure out which one of these has, and then we'll write something to figure out which one is the most, right? If A is greater than B and greater than C, then that's going to be the most, right? And we'll just do that 26 times to figure out which one is the most, which one occurs the most. Okay, we can obviously do a bit better than that by using lists and being a bit clever, okay? By being very clever, in fact, okay? So rather than doing this for loop this for loop is obviously very close to what we want. For go through every letter and then increment a counter. But rather than doing that, what we're going to do is we're going to create a variable called counts. Or count, doesn't matter. And it's going to create, and I'm going to hold 26 zeros. Okay? Does that make sense? 1 0 for each letter. Index 0 is going to be A. Index 1 is going to be B. Index 2 is going to be C. And so on and so forth until we get to index 5, and that's going to be index 25, and that's going to be Z. Right? Make sense to everybody? So now we have one variable to hold all those counts for every letter in the text. And now our next challenge is to make sure we don't write 26 if statements, right? So, right, because what we would want to do is if letter equals A, this is basically what we had, then counts of 0 plus equals 1, and then we'd have to do one for B, and one for C, and one for D, and that obviously would take a while, right, to write that out. I'd rather Python figure that out automatically, but it would work, right? So we'll leave that for later. Let's just assume we know how to do that counting now. Worst case scenario, we can count those 26 things. But now, now that we're done with the loop, assume we're done with the loop, now that we've got our counts, we can do this a bit easier now. What we can do is we can say, Okay? What we can say now is for letter in counts, and we can have basically best well, this is a bit tricky, but basically we can figure out which is the biggest, right? We can figure out which one occurs the most. Okay? But and once we do that, and we can just do that with a for loop and figure out which one occurs the most by basically doing a running comparison. So let's see how we can go about this. How do we do this automatically? Well, as I was showing, as I reminded you earlier, there's the CHR and there's the ORD function. CHR to convert a number to a character, and ordinal that converts a number to a letter. The other way around. CHR, which converts other way around. CHR takes a number, converts it to a letter, or it takes a letter, converts it into what number it's UTF-8, its Unicode value. The only important thing to remember there is that letters have values, and A, B, C, D are in order, and most importantly, ord of A is represented by 97. So what I'm going to do is, for every letter, I'm going to get its value. Value is equal to ORD of that letter. And what I'm going to do is I'm going to ask if that value is less than or equal to, if 97 to, and honestly I'm lazy, so 97 plus 26, right, there's 26 letters. Right? If that number's from A to Z, what I'm going to do, it's 97, 25, because we would have 97 being 0, and then the other 25 numbers after that. It's off by one thing. What we're going to do if we see that is that we're going to take that value. We're going to get the index by subtracting value minus 97 from that. Okay? Why? Because 97 is A, and we're going to go to 0. This is already getting a bit tough. So this is kind of the reason, already kind of justifying the fact that we want to learn dictionaries instead, because dictionaries are going to make this a lot easier. Okay? And now that we know it's a valid letter, that this thing is a letter and not, say, an apostrophe or a comma or space or whatnot, right? What we're going to do is we're going to say counts of that index plus equals 1. Okay? But now that's our entire for loop, fortunately, believe it or not. So again, this is just simply because we needed a way to convert from letters to our indexes, right? We get the letter's numerical value, say, hey, if the letter's numerical value indicates it's a letter, swap it to the range from 0 to 25, inclusive, and then just simply find the appropriate index and increment that count by 1. Now for letter in counts, we're going to have best letter, or let's go with, I'll just go most common letter. Most common letter is equal to, I'm going to assume it's A to begin with, okay? I'm just going to assume that the most common letter is A to begin with, and that most common count is equal to, and we've seen A, actually what I'm going to do is I'm going to just say our most common letter is the at symbol. Why not? Okay. And then I'm going to say I've seen the at symbol -1 times. That way, any letter I look at first is going to automatically be the best letter to begin with. Make sense? I'm just putting in dummy values, right? Okay. And so what I say is for index, comma, count, and this is one of my favorite functions, enumerate counts. This allows me to go over the index and the thing at the same, and the thing that's stored in the list at the same time. So we got to get the value back. I want to figure out what letter it is, and the way we do that is we say the letter is equal to the index plus 97, and then that's turned into a character. And I say if count is greater than most common count, we can be efficient and not have to do that until we are certain that we're swapping them. We say, hey, if we found a higher count, we're going to find out what letter had that higher count and say that's our most common letter is equal to that letter. And our most common count, our highest count so far, is equal to that count. And then we can print out most common letter, most common count. And we run this. And E occurred 45,000 times. Technically, actually, if I make sure that I do this first, which is letter equals letter dot lower, which converts everything to lowercase, 46,000. Okay. So completely an annoying problem, required you to know a bit esoteric stuff, but doable. You could follow along, and it was completely fine, and this is usable on anything. And then your professor, me, is a bit of a jerk, and he says, okay, now do it for the Mandarin copy. See, it suddenly became a lot more difficult because, we only have 26 letters, whereas anything using the Chinese-based character system has literal thousands upon thousands of different characters. And you want to find out which one's the most common one in there? So we need to rethink this because, we could have a counts variable and do the whole thing, but honestly, that seems complicated. So instead, what we're going to do is I'm going to make a new file, just a fresh copy. Going to call it file counting 2, and I'm going to copy in a bit of the stuff, just so that we have way less to look at. Documents, CIS 1051, no, CIS 1051. File counting, and we're going to call this 2. And now we're going to make a truly universal solution. So first things first, I'm going to take these first 2 lines. I'm going to take this bit over here because this was useful. Okay. Now rather than our counts being a list, we're going to simply create a dictionary. Now, the exam 2 and exam 3 aren't for a while, nor is the final, but each one of them will have a question that might not be a file reading question. In fact, most of the time you'll get the question that says given a string rather than given a file. But the point still stands. That just skips the first 2 lines. Okay? They can pretty much be answered by almost doing this code verbatim, just slightly tweaking it based on the scenario. Sometimes it's the most common word, sometimes it's the most common letter, sometimes it's the most common symbol, right? But they all are, but once you learn this and master this, this is basically how 90% of not just problems you encounter for my class, but just problems that use dictionaries in general are solved, okay? Dictionaries, you see, are used for 3 primary purposes in 90% of cases, okay? And like 90% of all statistics, that was made up on the spot, but you get the idea. Okay, first, generic key value pairing, right? Given a username, give me the data related to that username, okay? Second is counting. Given a key, the value is the number of times I've seen that key. And number 3 is what I call categorization, which is given a category as the key, give me a list of all the things in that category. We're not really going to see that third one in this class. And most of the time, we're going to be working with this other one, the counting one. So counts is equal to an empty dictionary. And what we're going to do is we're going to say for letter, even though it's going to include stuff like spaces, but we can filter that out later. Okay? For letter in text, I'm going to go ahead and grab that letter. And I'm just going to ask the dictionary a simple question first. Have I seen this letter before? If letter not in counts, that asks, hey, have we seen this before? And I'm asking if the answer is no. Have I not seen this before? If I've not seen this before, well, I've seen it once now, right? So I'll say the counts for this letter is equal to 1, because I've seen it once now, right? Have I seen it before? No. Well, I've seen it now. Otherwise, if the answer to this was, yes, actually you have seen it before, then I'm going to do this. Counts for that letter plus equals 1. See? That's all that is. Just simply, if I've not seen it before, oh, I've seen it once now. If I have seen it before, well, I've seen it one more time now. So increment that by 1. And that's it. That is it. That is all there is. No weird math, none of that. We are just simply going to go ahead and print this out and see what it looks like. And it is an unorganized blob. Okay, so this first thing, this slash UFA, right, that is actually like a special hidden beginning of the character file at the beginning of, this is like a letter, a special symbol saying, hey, this is the beginning of the file. That's all that is. I don't know why they couldn't just remove that, but that's what it is. And then you'll notice that the first 3 letters it saw were THE, right? And then a space. But it's got counts. It saw the capital T 656 times. It saw an open bracket 4 times. It saw the number sign once. It saw the letter 8, the number 8, 18 times. Right? There were 61 colons. And the $ occurred twice. 1 capital Q. Right? So it's a bit of an unorganized mess, but we can at least go through it now, right? And we can filter out the data later, but this is it. To look for every single symbol in the file. That's all it took, right? Every single symbol in the file, that's all it took. And that will work on any language because it's literally just looking symbol by symbol. Okay? That's pretty cool. Okay, now how do I figure out what the most common thing is? Well, for letter, and I'm treating everything, including the space and the number and the $ as a letter, right, just for sake of argument, in our counts, what I'll do, we do basically the exact same thing we did earlier. I'm going to assume that the most common letter in this case is, I'm going to assume it's something I'm going to assume that it's the at symbol again, and I've seen -1 times, right? Or whatever. Okay? And what I'm going to do is I'm going to say, hey, for lettering counts, if the count of that letter is greater than the most common count, then our most common letter is now equal to that letter, and our most common count is equal to the number of times I've seen that letter. And then finally, all I have to do now is print, do the exact same print statement I did earlier, which is most common letter, most common count. I like Geany, because this text editor I use, because it is very bare bones, doesn't really have any it doesn't like do any of the scaffolding, but it does have the most basic of autocompletes. But that autocomplete, the way it works is that it's just simply working off the variables that you yourself have created. So it doesn't mean, so it's not like suggesting, oh, here's how you do a try-catch block. It's keeping it very bare bones, very minimalistic, which is good for you when you're learning too. And so it says nothing over here. Why is it saying nothing? Print. Oh, most common letter, right. Most common letter, most common count. I know exactly what's going on here. And it's showing me 71,747. This is actually a very unsurprising result if you think about it for a second. It's telling me that the letter, the space, or rather the symbol the space, has occurred 71,747 times, which makes sense. That's the most common thing, because everything in English is separated by a space. Every single word is separated by a space. So basically, that's also very close to the number of words in the file. So of course that's going to be the most common symbol in any English text. Okay, so let's go ahead, and now that we've got our basis, we can just simply filter this out a bit by using a bit of what we learned earlier, which is that we can say, hey, if letter, and we can do either the numerical version, but honestly, right, that a lot of students are going to be like, I don't remember how to do that. So whoops. So what I'm doing over here is that all I did was I just went across my keyboard. Okay, that's all I did to get all the letters. That's why they're in that weird order. But what I'm doing over here is I am just saying letter is equal to letter dot lower. Again, so I'm converting it to lowercase. I'm avoiding doing all that funky stuff with the numbers, right, and translating text to numbers. All I did was saying, basically, if letter is in A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, except I just did it in the QWERTY order in your keyboard, right, because that was easier than plucking it out, right? If it's a letter I'm looking for, if it's not one I've seen before, I've seen it once now, otherwise I've seen it more than once. Now I'm just counting the actual letters, and we get the same thing we got before, which was 46, which was around 46,000. And again, this is only if I want those letters. If I cared about those symbols, those other symbols, I'd do what I just did there, right? I'd remove them. So this is again a very, very powerful option for us. And we saw that earlier now, so we can go back here and see this now, how what I'm doing over here is I'm creating this association between your name and the rest of your grades. So I can just simply look up and say, hey, John Doe has these grades. And so then I can take that row of data, which is just a list, and add it to another list over here to do that. That's all that happens over there. And then write it to a new file. And then I upload that file to Canvas, and it says, oh, we've detected new assignments. Are these new assignments? Yes. And so then occasionally I say, no, that's weird. That's not a new assignment. But yeah. And so these tools are extremely, extremely powerful. Now, the next homework that we'll be using, which I think will be like the final homework, which we'll do, and I'll give a bit of an extension on that one as well. Do people need an extension on the current homework? Vigorous nodding. Vigorous nodding. Vigorous nodding.
You need to
No, I meant the current homework, which is the hurricane tracker. Yeah. Okay, we can do that because also, I made it due on a wellness day, which just does not seem great for mental health, right? You should probably make that argument at some point. All right, let's go ahead and see where our assignments are due. Okay. Edit. We are going to make this due next Wednesday. We are going to make Hawaiian pronunciation due right before Halloween. Pig will stay where it is, but it will be transitioned over to being an extra credit assignment. So that means that's why you're going to see it at 0 points. Okay, so I will assign whatever value I deem appropriate, and those the way that'll work is you'll get like 20 points out of 0. Okay, and that just gets added to your grade. Now, my intention is to do what I do for Pig, which is to go over it in class. It's an 8-part problem, so I'm going to go over the first 4 parts at least in class and leave the rest as an exercise, as an extra credit exercise for you. Because what happens is at the beginning of November is around the beginning of November is where we're going to start talking about our final project. Around a couple weeks time, actually, we'll start. What I've got is I actually went through the trouble this semester of going through the previous best projects and compiling a list of them that I can share with everybody. Okay, and what we're going to do is I'll send that list out, but I'm going to spend a day going over in a week or so, like the different options, as well as talking about GitHub and stuff like that, and how to do that. And because I've got some time left, I'm going to just talk about that briefly to kind of de-stress everybody, because hey, we're in the spirit of mental health stuff. First, there are 4 steps to the project. Okay. First is what is termed, and I stole this from the Harvard CS50X course, which is their open source course. It's pretty good. The first step is what we call the pre-proposal or brainstorming. Very straightforward, very simple there. It's basically got 2 objectives. One, creating a GitHub repo for your project, and 2, basically start thinking about. 3 points. 2, start thinking about if you want to work alone or with a group. And 3, start thinking about the kinds of things you want to work on. Okay? So the second step, which will occur early in November, is what I call the proposal. And that will happen on what I call Proposal Day. That day, whenever I choose it, will be held over Zoom. I will cancel class in person and we'll hold it over Zoom because I need to meet with every single group or person who's doing this final project. You don't get a choice in it, but I need to meet with everybody, okay? Because I need to hear your proposal and give you the okay on it, okay? And tell you whether it's too easy, too hard, or, yeah, that sounds too hard, but if you can get this part done, I'm going to be very impressed, okay? So I'm just trying to help you make sure your expectations are within reasonable limits, right? Okay. Now, the reason that's going to be over Zoom is because once you've proposed and I've given you the okay, you're done. You can go. You don't need to stay for everybody else's. And what I'll do is I'll ask people to basically order themselves in breakout rooms based off of how long you can wait, right? Because normally this takes 2 hours rather than 1. So if you have a class right immediately after this one, obviously I want to see you first, right? Whereas if you can wait, you can let me know, hey, I'm going to be coming in at at the end of class to propose. That way I know that I should wait for you on Zoom, right? But I'm going to basically be going person by person. It's going to take a couple of minutes for each person. Yes?
How long does it take for the proposal for each person?
It's anywhere between 15 seconds to 2 minutes per person. It depends on the person and their idea. Some people, and if you already have an idea, feel free to come by during office hours, and I can just simply handle that then, and you won't have to show up, okay? So step 3 is due about a week and a half before the final project, which is the progress report, or the, hey, if you haven't started working on it, maybe consider doing that. That's what the main purpose of that due date is, because while you're not going to have any other homework to work on, I want to make sure give you a reminder that you are working on this, because you may not know this, but people are terrible at doing deadlines unless they're looming, you know? So time management is kind of important for that one, but basically it's my reminder to get you kicking into gear. And then the final project itself will be due on the very, very, very last day of class. As I mentioned earlier in the semester, there is not really an extension I can give on the final project. If it is late or something, I need you to turn in what you have. Now, you'll understand why, like, just if it's on GitHub, I can see, like, even if you were out of commission for some reason, that you had done the stuff. That's the part of the important part of doing GitHub. It timestamps everything. It timestamps all the changes when you manually make them. So it'll be very, very good for that. But I don't give extensions on the final project. I do want to see what you have learned in that time, because depending on the schedule for finals, I need to be very quick around with the turnaround time. Basically, that Monday, they turn in. Tuesday, I spend then watching all your videos of the final project so that I can say, hey, this, because you may have forgotten this at this point, the best final projects get to skip the final exam, okay? So that is my incentive for you for doing more than the bare minimum, okay? There are a couple of default final projects I give out to people if you don't have an idea. So if you are panicking about not being able to find an idea, the default idea I give most people is do a visual novel in Ren'Py, which is a Python-based platform for making which are visual novels. And I'll go into an example of one of those later. But like visual novels made in Ren'Py include some of my favorite games of all time. For instance, there is Doki Doki Literature Club, one of my favorite games of all time. If we look on Steam, right? It looks like this nice, cutesy game. I would just, it's wonderful. It looks like one of those Japanese dating sims, and very deliberately so. I would mention that you should maybe take a look at the tags for the game, though, and just simply, psychological horror. Yeah, it is a great game. It is wonderful. But that was made in Ren'Py. Similarly, a game I really loved this past year was Slay the Princess. That was also written in Ren'Py, another horror novel. This one was great. Slay the Princess, a pristine cut. If you don't, it will be the end of the world. It's a great game. If you haven't had the chance to go in blind to it, I highly recommend it, although not if you're easily disturbed by violent content. It's very good. But this platform makes it great. And visual novels have gotten best project considerations before, especially when I see that a lot of love and effort went into it. When I see that when the programmer did not just do the programming for this short game or short novel, but they also did the art, however good or bad at their art was. Putting yourself out there like that is really big to me. And same with the music. Creating the audio assets, that does a lot. I'm going to leave you with actually showing you probably my favorite game of all time that I've seen. So from this notes portfolio, there's a document, best projects, README. So this is probably one of the best games I've ever seen done for CS 1051. Okay, and I'm going to turn down the volume in case it's way too loud. Okay, so this is
Hello.
Hi.
Let's go ahead
And we are freshmen, and this is our project, Hand.
Okay, let me go ahead and make sure that I am in doing this. And let's see. Open volume mixer. Am I? Yeah, it's outputting to here. Oh, that's why. Okay.
Yeah.
I don't know why the volume doesn't go on this.
I'll be providing the gameplay.
This is a 5-level little mini game. All the levels exist in the same space, and the camera, all of the like 2D objects are in a 3D space, and the camera basically just goes through them to switch levels. I wrote the music that is in the background, and I'm also the main character. I feel like some of the difficulties in this were definitely getting all the animations to work, and also to make all the like proportions pretty accurate and right. That was pretty difficult.
I love that
Transitioning
shrinking
between each
duck
level,
animation.
also
It's
trying
one of my
to
favorite things
figure
about
out
this.
How to move the camera, and how to.
To me, they took some very obvious inspiration from the game WarioWare for this, which is this just wonderful Nintendo game, micro games, which are these small little levels. Like each of these levels would be considered an A, by the way, on the project.
It's a pretty funny concept too. Punching
So keep that in mind. Each of these mini
there's a
micro
boss
games would
fight
be
at the
considered
end.
an A in my book.
Yeah.
And so by doing them together,
Sorry, I
putting them
spoiled it.
together like
But
this,
yeah,
doing this, adding to the music
I
each
love
level,
making the game,
it gets,
a lot of fun in the
you know,
class.
this is what made it get the best project. So, now this, how did they do this all? This was done in Unity, which is a platform that it's used by professional gaming companies. There's 1.5 million tutorials on how to make stuff in it. It's
157.
great. And I don't expect you to know these things going in. The entire part of this process is to learn how to do these things. The entire point of the final project is that I am throwing you into the deep end of the pool to show you that you do actually know how to swim. With that, have a great weekend.